All right, I'll send this out as an announcement as soon as class is over before I go run off to a meeting, but I had only about half of the students actually complete the assignment this week. And as we look at it, that's kind of a serious issue. So I'm going to extend the due date until midnight tonight, and hopefully people will be able to get this done and turned in. There is also a discussion board that a lot of people chose not to participate in. Those points add up, and zeros certainly count against you. So make sure you go in and you've got both of those done on that assignment. I do try to respond as quickly as possible if you have questions, but this one you should be able to do, hopefully. There's a lot of resources, materials. If you get stuck, go out and look at some of those resources we've created, coding sites, the Python site itself. Go out and look at some of those options and different things. Make sure your program runs. If it has an error, the most common things with errors we find are you miss things like a parenthesis or a colon. And so usually, if you get it says error in line 28, look above that. That's my hint, is to look above that. Make sure your variables, you don't change a variable name somewhere, adding a capital letter or leaving off a capital letter. It's very case specific on variable names. So if I call it point with a capital P, that's different than point with a lowercase p. All right, so this week we introduce a couple of new things. So we looked at what last week we called them a list of items. Well, we're going to extend that a little bit. Those tuples, we're going to look at how we can extend that a little bit and make them a little more powerful even. And so one of the things that we're going to do, let me open up a program here. All right, so I need an idle. Open new file, drag that over so you guys can see it, is we're going to change from just a typical list. And one of the problems with the list is that we can't change that necessarily, the ones we've already got, the tuples. So we're going to make your lives really miserable by introducing another data structure this week. And this one our book calls a list. This one I think of as more of as an array, and it's really complicated, the difference between them. You want to know what the difference is? Does anybody know already in there? Have you looked ahead? What's the whole difference between a list and a tuple? It's one symbol. So when we created a tuple, we said, all right, so we have, just so I get in the habit of it. So I said, we'll call it inventory. And I said, I put a parenthesis and I said, sword. Shield. And I'm just going to have two items in there. And I know I can add to them. So I can add an item in there. But I can't necessarily manipulate it as much as I would really like. I know I can print that entire inventory. Remember, inventory really is a variable, even though we're putting in multiple items in there. And so run, let me save that as, and so I can run this. If I remember to put an equals in there, it'd be helpful. So I can run that, and it's going to say, hey, you have a sword and a shield. And I can work my way through those. I can create a loop to go through those instead if I wanted to. So I could create a loop that said 4 items in this list and print out all of those. So there's a couple different ways we can get things out. I can even do this. So I could say, I want to print inventory, but I want to print a specific item in that inventory, and I just want inventory 0. Okay, I can do that. That one's pretty easy to do. And now I'm printing out 0. So item sword. So, and it'll just print out that particular item I want. So these same tools, so we have a couple of other things that are kind of handy to do in here. You can do some slicing, and we can add pieces and all different kinds of things. But the reality is we're a little bit limited by this idea of that tuple not being able to be mutable, in other words, changeable. So if we could come up with a way to do something a little different, and we could change all those, maybe life would be better. And we can. And we're going to do it this way. So that parenthesis, if I replace it with a square bracket, oh, that was really hard. I just made that from a list that I could not manipulate to a list that I can manipulate. That easy. So now I can actually add and change things inside of there. With the original idea, that tuple we had, I could add two tuples together and I could add an item at the end. With the idea of I putting this in a list, I can actually manipulate this in a multiple of different ways. So I'm going to add a couple more items just so it makes it a little big. So I can have some items to play with here. So let's put in healing, potion. Let's put in bag of holding. What other things could we get in from? Let's put a dragon in there. So all kinds of weird things from Dungeons and Dragons. And in fact, let's see what happens now. Oh, still works, still printed my sword out. So nothing changed in how I access this list that we changed from a tuple to a list. We made it what we call mutable. And I can do where I print, so for item in inventory, if I spelled that correctly, print item. So what this does is goes through as a for loop and assigns item as it goes through. So it becomes sword, shield, healing potion. And so we could do that and print. And that way it'll print as a nice, neat. Let me see if I can make that a little easier to see here. So it'll print that as a nice, neat list down here. So sword, sword, shield, healing potion. And you go, why did it print sword twice? Well, that's because I still have this print in there. And one of the things that's really handy, especially when you're trying to test code, is I can put in that pound sign and I can eliminate that line temporarily. So now I've created this much bigger list, and I want to do some other things with it. So just so we can hold it up for a little bit, I'm going to snag my input from the very bottom, which I should have had in there already. One of the things I've seen in people that have turned in code already is they've not got this input at the bottom of their code. And we'll show you again why that's important. So this input now is going to wait for us to do something. And I want to figure out how many items I have in my inventory. So the same structure works. So I'm just going to put this all in one line. So I'm going to print, you have, and I can put this inside of a print statement. Now, I could have went out and found a variable, created it, but I'm just going to do the length of inventory. So now, if we've done that right, it's going to come up and it's going to say, hey, you have so many items in your backpack. Now, the other thing I'm going to do, and it's still in my copy-paste, is I'm going to put another input at the bottom, just so it'll hold this program open again. So I'm going to run it, hit my F5, And it says, oh, you have a sword, shield, healing potion, bag of holding, and a dragon. Press the enter key. And it says, oh, a bag of holding. You have 5 items in your backpack. Interesting. Let's make sure that's right. So, 1, 2, 3, 4, 5. Remember, they're numbered 0, 1, 2, 3. And so we could check that on any of those. We could say, well, let's print item 3 and make sure it actually does print that correctly. And so it does print that bag of holding, which is number 3, 0, 1, 2, 3. What happens, though, if I get outside of there? And that's one of the advantages to that length statement, is I can programmatically search for these things rather than put in a hard number. Because if I look at that and I said, well, I think I have 5 items and I want the 5th item, and I put in a 5, it's going to crash. And it's going to say index out of range, which is actually a better behavior than it trying to find what's in there. Because we don't know what's in that space. There's nothing been assigned, and we could get garbage. We could get something from another program. We could get something from our own program. So that length statement allows us to know how long it is in any case, and we can use that as a way to maintain that safety of those. So I'm going to take that one back out temporarily. So we can do some other kind of interesting things. So one of the things that we can do is we can search for items inside of an array. In every other programming language that I know of, well, with the exception of some ones similar to Python, but the lower level ones, like if you're looking at C++ or the old BASICs or any of those, if I wanted to search for an item, I'm going to have to create a loop. And you can do it this way. And you would do a loop like you did here. And then you would say, instead of printing that item, you would then have an if statement. If item is equal to sword, because maybe we're looking for sword. And then we have a condition if it's true. Then we say print you have a sword in your inventory. Well, and that works. And we could do that. And you could actually put that in as a variable and say, input a variable and say, do you have this in my inventory? And you could search through. And that works. But Python, being really nice to us, actually allows us to directly search through those. And so we can actually do this. So I'm going to delete that junk now, temporarily, because that's how it actually works. But what we can actually do is we can actually just put in if, and I think we looked for a sword, if I remember right. If sword in inventory, we can do that directly, and it will actually search through that entire list, no matter how long it is. And then we could do a print. You can slice and dice as you have a sword. And so I'm going to try to check this and make sure it really does work. So F5. So it went through my list and it shows me everything that's in there. All right, I don't care at this point, but you have 5 items in your backpack. Yep, you can slice and dice as you have a sword. All right, so just to make sure that it really does work, I'm going to change that from sword to word and hit F5. And let's see if it actually does work. Huh. It actually does. It searches through that inventory or that set of variables and can find that for me. So that's actually a really handy thing to do. If I want to find a something inside of there, I can do that We can put things out, we know, at specific items. So we know we can do that. So we also can actually slice up or change this inventory really easily. So one of the ways we might do that is we might actually ask and say, hey, I want to start at a specific point and end at a specific point. And so I'm going to do a couple. I'm going to do start equals, and I'm going to do an input. Please enter the index where you want to begin. Now, and I'm going to do a finish. So my question, and when I start looking at this, is, A, there's something wrong with this to start with that you should realize. What do we have missing from in there? So anytime we take an input, does it come in as a number or does it come in as a string? So if I get any kind of an input, what does it start out as? It always starts out as a string. So we have to actually do a second step in here. And so we actually have to use, in this case, I want integers. So I can put in int. And so it's passing this entire thing into an integer function. And so whatever we input will become an integer. Now, here's the problem. I really should write a whole piece in there to validate that input. So I should actually have it in like this. I should say, all right, while start greater than or equal or greater than 0, because we don't want to go below, although we can actually use negative numbers in that list. It just doesn't work quite like you think it does. And start less than length of inventory. So we really should do a test, and then if it doesn't meet those conditions, we ask them again. Well, we're going to cheat a little bit just for the sake of expediency, and we're just going to assume you know not to put in values less than 0 or greater than 5. So for this, we're going to do that. The reality is you should create a module that says, I'm going to error check to make sure that my user is not an idiot. Even if you put it, you could also put in your print statement here, please pick numbers between 0, and you could use that length function we did earlier. So we know we have 5 items. You could use that again. Users are always going to be idiots. No other way around it. So, but for now, I just want to get a couple of inputs. I want you to be able to slice up what you're doing here. And so I'm going to print inventory. If I get on the right row here. Inventory. And I'm going to say, here's my start. And I just put the quote mark around there so it'll have that. Finish. And so I want to then, so right now if I run this, it's just going to repeat those numbers back. It's going to say inventory, and I probably should say from start to finish, and it's going to tell me those numbers, echo them back, whatever I put in there. But what I want to do is slice up my inventory. And so I'm going to have a second print statement that's going to say inventory. And again, I'm going to put those brackets in, and I'm going to just do this. I'm going to say start, finish. And by putting that colon in there, it's going to start wherever we are at and go all the way to the end of what we ask it to do. So we're able to slice that up. Now, one thought I had is, does it list this, and if I said start at 0, and it gets 0, is 0 the S or is 0 the entire sword? And I think we've established inside of these list items that it really becomes this, that entire sword becomes that. So we can check it, and this is a great way we do that. So you can slice and dice. Well, where I want to begin, I'm going to begin at 2, and I'm going to end at 3. Inventory from 2 to 3 is healing potion. So we went from the end of 2 to the end of 3, and so we get healing potion. All right. So we can slice those up. We don't necessarily need to just grab one item. We can grab an entire slew, and I can do the same thing. And if I want to go from index I want to begin, let's say 0, 4, and now it actually has all 5 items in there. So we can slice and we can manipulate these things around pretty easily. So just like we could with a tuple, so we can also do something a little different. And I'm going to bring it up here so we make it a little bigger just to see. We can actually add another list in there. And so I'm going to take a list up here, and we'll call this backpack maybe. And I'm going to assign it some values. And I'm going to make sure I put it inside the square bracket here. And maybe this one is where you have your rubies, gold, coins, worthless, dollar bills. So now I have another piece in there. So I want to add those 2 items together. So right here we printed them off. And so I'm going to just double check, and I'm going to see if we really can do that. So inventory, and I'm just going to add chest into it. I'm trying to work my way around because normally what I would have written, just out of habit, equals inventory plus chest. Because to me that more explicitly says what I'm doing. I'm adding those in together. Doesn't make a difference which way you do it. It's the same thing. So now I'm going to list those items again. I'm just going to copy this down and see if it really did put all those items in there. So, uh-oh. Oh, backpack. That's what I call it. Good call. Works better if you actually have the right variable in there. So notice the first time it went through, it said, and our dragon. The second time, now it actually did. It added those 2 things together for us. Not very elegantly. And I don't have any line spaces or anything in there, so it's kind of ugly. But we can see that it actually did add those pieces together. So we can add those together. Now, I'm curious, just because that's the way we learn, what happens if I try to add two different types together? So here we have our list, here we have a tuple. So let's see what happens if we try to add those together. Oh, interesting. It actually allows us to add those 2 items together. Even though one's a list and one's a tuple, we can add those together. And that gives us the ability to, say, convert from, so we have our friend here is in a tuple. And sometimes we like to use tuples because it isn't mutable. So we kind of use it as a way to store items that we don't want them to change. So that gives us kind of a neat way we can do things. Well, now we've got all those items in there. I'm going to put a pound sign in front of that just so it becomes non-printing. And I think I'll do the same thing here, just taking it out temporarily. So we do want to leave this in where we add those two items together. So now we've got a much bigger list. And in fact, our length now down here is actually going to tell us that you have 8 items in your list. Now, I did something weird there because I just canceled out of it really quickly. So we have 8 items in our list. That makes sense. When I put in a blank null character is why it crashed on the start and end of our slice. So now we could go to 0 to 8, 0 to 5. But I want to be able to see if I can trade out items. Because before, I couldn't directly switch out an item and delete an item or trade it. So I want to see if I can assign an item. Where you can see it again. So right now, the last thing we did was we print out an inventory from our start to our finish that we typed in. But I want to trade and I want to change something out. So the traditional thing that we look at when we say we're going from war to peace is we trade our swords for plowshares, right? We've all heard that literary piece. So we're going to see if we can actually do that. So our sword is actually number 1, isn't it? Or is our shield number 1? I can't remember which one we've got sword. Sword is the first person in our inventory, which is really position 0. So I'm going to do a real quick print just to explain what I'm doing. So I'm going to trade in my sword, and I want to see if I can do that. So inventory. And I know what position it's in. I know it's in position 0. And instead of having a sword, I'm going to assign it the value of plowshares. So let's see what happens. So we can do that. And so I'm going to print out the entire thing. So I'm going to just print inventory really quickly. So now it's going to print it, but as a line all the way across, hopefully. So, all right, enter the slice you want to begin. 1, 2. I am trotting my sword in as I found peaceful hippies embrace their culture. And so now, notice it says it's plowshares, shield. So I can actually change that. If, however, I come back in here and I said, you know what, I'm going to go back to the way the previous chapter showed me, and I put in a parenthesis, making that a immutable tuple. Let's see what happens. So 8 items. And I can still do the slice because we could do that with those. But notice as soon as I do that, it goes, oh, no, tuple doesn't support you just directly replacing them. So this is a far more flexible way for us to create items. And it makes them kind of useful because now I can change those. I can even change this even more. So that slices that we used before, I can change that even more. And I want to look at, where did I put my, so rubies, gold coins, and worthless dollar bills are in position. So 0, 1, 2, 3, 4, 5, and 6. So 5 and 6 and 7 are some dollars. I want to see if I can change multiple items for a single item. So I'm going to try this. So I'm going to say inventory. And instead of just putting in a single value, I know that positions 5, 6, and 7. So I'm going to put 5, and I may be wrong on that. So we'll see if it works. 5 through 7 are going to be assigned incense burners. So I'm going to trade that all in for some incense burners. And now I want to do another print inventory. And see what happens. So you have 8 items. Great. I can slice and dice. So I'm going to go 5, 7. And it tells me that it's in rubies and gold coins. So here's the first time I'm trading my sword in, and it did change that to plowshares. The second time, I'm going to change it. Oh. And it did something kind of interesting. So notice it changed it to incense, but what did it do to it? What did it do to incense burners? It put them all in as individual words. Oh. So there's a little change we need to make in here. Because we're doing multiple items, watch if I do this. So 2 symbols, we're just saying, hey, we're adding in a, even though it's a single item, we're telling it we're adding in a list into the list. So, and we'll see if we can do multiple items in just a second. So yes. You have 8 items in your backpack. Ooh. Where do I want the index to begin? I want it on 5. I want it on 7. And notice now, so it changed plowshares, and now it changed it to incense burners and worthless dollar bills. All right. So that actually kind of did what we wanted it to, but can we add multiple items in there? So maybe I wanted to change out those dollar bills for not just one item. What other things do peaceful hippies? Peace signs. Let's just put some peace signs in there. And let's see if it will work for that also. All right. And so now we changed it to incense burners and peace signs and worthless dollar bills. So we can change in and we can add multiple items in there. We can check through our list. So it's really a powerful way to do that. So we have a couple other things I want to look at. And so now we've built this giant inventory. And as we did that, we know that dragons are an endangered species. So I want to take them out of the giant magic backpack I have or whatever it is. And I want to see if I can delete that dragon out of there. So the first thing I need to know is what position is that dragon in? And so luckily I can come in here and I can say, all right, well the dragon's at, so 0, 1, 2, 3, 4, position 4. And I have that knowledge. So if I have that, I'm going to do a couple of things here just to make this a little easier. It's getting a little long as we just go through there. So I'm going to delete out a couple of these print statements. So I want to delete out the dragon. We know it's in position 4. So just so I can remember what I'm doing, I'm going to print out, we are releasing the dragon to the wild. Well, this is pretty tough. Everybody hold on for your hats. If I want to delete something, what do you think would be a key word? So we shorten it, so it's just delete as in DEL, inventory. And I put in the position I want, which is position 4. And now I'm going to put a print inventory. And see if it got rid of that item that we wanted. So here's my 8 items. We changed it, we got instance burners, we released the dragon, and oh, the dragon is actually gone. Oh. So we can actually do that with a slice too if you wanted to. We can slice through an inventory. What happens if I forget to put a value in there and I just say delete inventory? So it doesn't allow me to delete the entire thing quite that easy. So it doesn't destroy it as easily as we thought, but we have a lot of ways we can manipulate things like this inventory. So I do have to know what it is, but I can do the slice in there. I can do 2 through 4 if I wanted to. And so now you notice it's pulled out a couple of different items. So it didn't pull out dragon. Dragon's at position 4, so we'd actually have to go to position 5 to get it out of there, if you look at the way those slices work. So if I come back in here, I change that to a 5, and maybe we just go all the way from 0 to 5. And now it took out everything except incense burners, peace signs, and worthless dollar bills. So we can manipulate around those items inside of a list. And that actually makes life kind of easy for us, or more interesting, I think, because it allows us to do some things where we manipulate them inside. So very similar to your jumble game, now we could do that inside of a list, but with multiple items. So we have that ability to do a lot of different things. So one of the ways we can do that, one of the ways we can also get some interesting things is through a dictionary. So there is another type of data structure called a dictionary. And a dictionary, hold on, this will be tough. So let me see if I can just make a beginning up here. So we said a tuple can't change, and it was the items inside of a parenthesis. And so now we have a list, or an array, a true array that we can change, and we had the brackets, right? And now we're going to have something called a dictionary. And a dictionary, if you look at a dictionary, it pairs a word and a definition, right? And so we actually have a structure that actually works like that. So it pairs a word and a definition, because we use that quite a bit. So the brackets that we're going to use for this to tell it that it's a dictionary item, if I look above the square brackets and you have these weird little curlicue brackets, so a dictionary item, so item, and we'll just use the word item, chunk says our word, so dictionary, and we put a colon, So that is our first dictionary item right there. So we have our list. We know we can change those. Dictionaries are a little different. Dictionaries allow us to match those two items up. So if you think back to your program with your hints, some people looked ahead and actually said, hey, here's my word, here's my hint. And we'll show you how we can work some of those. So what we're going to create is something called the Geek Translator. So we're going to create a program that does a couple of things. It's going to show you how the dictionaries work, and we're going to create a menu structure. We haven't really done that yet, but menus start to become important, and you see them all the time. Almost every app, every program, every game you go onto really comes up with a menu, and it says, hey, press button A to start the game, press 0 to end the game. And so we're going to do a couple of things. So I'm going to start a new one here. New file, blank. Oops, wrong window. And we're going to create, and we're going to call this our Geek Translator. And make sure you put your name on everything you do, and you're going to save it as a Python file. So we're going to start, and we're going to call this Geek. And we know that we're going to use, and I'm going to end it down a couple lines just so I can say that I have content in there. And so we're going to put in terms in here, and we'll create those terms here in just a second. We may put in one. Let's put in Python. Just so we have the start of one here, okay? And we're gonna do that for several different items, and we'll be able to see those. So for right now, we're gonna move on to some structure, and we'll go back in and add some in depending on our time. So I also am going to introduce a nulled character out. So I'm going to put in a menu in this, and I want to show you a menu structure, how we can do some of these things. So I'm actually going to use the word choice, and that one we use quite a bit, and I'm going to assign it the value of none. And notice when I do that, none turns orange. None says, hey, there's really nothing in here yet. So we're going to assign it a blank value to start with. And I'm going to put my entire program from now on in a loop. So while choice does not equal the value of 0, so as long as you don't put in 0, you're going to keep running this program. And so the first thing we need to do is put a print statement in that explains our menu. So I'm going to do a print. And this one is one where that triple quoted thing is kind of a handy way to do it. And so triple quotes allow us to put multiple lines in a single print statement. So I'm actually going to cheat temporarily, and I'm going to copy this really quickly just so I can save a little time because I'm looking at the clock here. And this is straight out of your book, this portion. So this Geek Translator, our menu actually has a couple of different pieces to it. One more quote string there. There we go. All right. So we're going to have quit, our 0. 1, look up a geek term. 2, add a term to our list. 3, redefine one. In other words, we're going to change its meaning. Or delete a term. Now your assignment this week is to create a list of words that you can change and add to. So you're going to build a menu structure very similar to this in your coding for this week. So now that we've got this, and here's where that indenting comes in. Because we're in a while loop here, our entire program needs to be over in this realm, this indent. As soon as I go back, so if I go back here to that outside indent, I've already exited that loop. I'm done with that loop. So I need to be in one indent space for that. And so I'm going to first get an input from my user. So choice equals input. Now, what that does, and we don't necessarily need, because we're going to compare them. So my first thought would have been, oh, well, I need to take that integer of that. But we can compare, because we're just asking for an input and we're just comparing them. We can leave them as a string for now. So what we have now is we're going to have a set of if statements, or actually the elifs and that. So we're going to say if, so we can just compare our choices. So if our choice equals 0, print goodbye. So we're kicking them to the curb. So our next choice then, we're doing an elif, and our choice, if it equals 1, if our choice equals 1, now we're going to do something with that. And we're going to have to, in this case, we're going to have to look up a term. So I've got to figure out how to translate a term that they ask me about, and I need to be able to see if that term is actually in our list. So a couple of things are going to be happening here. So we're going to get in a value. So in this case, maybe we'll just call it term equals input. Please input the term you want defined. So that's going to get a value from our input. And it's going to say, all right, well, we're going to get some kind of value in. Well, I don't know if that whatever they type in is in my list at all, but I have a way to check. So I can create an if statement inside of here that says if term is in geek, and so if it's in there, then I can create a definition that's equal to geek, and instead of passing in an index value, I pass in that term. So this is kind of handy because I don't have to put in the index as a position. I put in this case, the only thing I have up there is Python, but we can add to that really, really easily. And so I pass in that value of Python, and so now I could print out, get a little taller there real quick. I could print the definition of your term is definition. All right. Now, quite frankly, I could actually put this piece directly in my print statement, But I just wanted to make it clear that we're able to pull that out this way and assign it to another variable. So right now my program's got a couple of pieces. It's got this if it's in term, yep. So we need something for if it's not. So the other way we can do that, then else print don't know that term. So now this program at this point should be able to take an input, and if it's 0, kick you out. If it's 1, it should be able to look for that term. So I'm going to save it really quickly before it deletes itself. And I'm going to say geek translate. And so, oh look, it pops up, it says choice. And I'm going to try the 0 and make sure it actually does quit. It says goodbye. Hey, that part works. I'm going to try it again. And I'm going to say I'm going to look up a geek term. And the term I want is nerd. And it says, yep, don't know that term. So I'm going to run it one more time and put in a known word just to make sure all the possibilities work. And please enter the term you want defined. And the definition of your term, Python is world's coolest programming language. Got it. Well, that works pretty slick. So now I need to finish out a couple of these. So I know how to look up a term. That one seemed pretty easy. So I want to be able to now add a term. So LF choice equals 1. So I need to make sure I'm at the right indent level. And so I go all the way back out to where this LF is here. So LF choice equals 2. I'm going to do something else. So in this case, some of this stuff is very similar. So I'm going to use the same value, term equals input. Please enter the term you want to add. Now, I'm doing this very quickly and not making it very pretty, but there are some things that would make this a little nicer as you finish. But I'm just looking for some structural coding. All right, so the first thing I'm going to do is, because we don't want the same term in there twice, right? So we're going to first check and see if that term is in there. All right. So if term in geek. So if term is in geek, I want to say that you're going to re-exist. So I'm going to change this just slightly. So if term not in geek, and notice they're orange, they light up. So we're looking for, as long as you search through and you don't find that term, now we're going to be able to add it to my list. Not in geek, we're going to do something. So we're going to create a definition. So we've already got the term, we just need to get that from them. Input, please enter your definition. And you could remind them what their term was and all that, but I'm just going to get a definition. And then I'm going to assign it, so geek term, because what they assigned it, equals definition. Because remember here, we're pairing it with a word pair instead. And then you could confirm it with a print statement. Your term has been added. So it just confirms what we looked at. I'm going to put an else in there. And so the else is what happens if the term is in there. So we have a negative here. So the else is saying that we found that term. We found your term already in the dictionary. All right, so I'm going to try this again and see if we can do that. So we know we can look one up, and I'm going to see if we can add a geek term. And the term I'm going to add, what's a geeky word? Lab. Nobody jumped up really quickly. I'm going to add in the word lab. And it says, oh, it checked it. It's not in our list. A place nerds hang out to do homework. Oh, your term lab has been added. Well, just out of curiosity, I want to make sure it's in there. So I'm going to click 1 for look up a term. And I'm going to type lab. Hey, the definition of your term lab is a place nerds hang out to do homework. Well, that's pretty slick. I'm going to try it again. I'm going to try to add another geek term. And I'm going to enter lab again. Let's just say, hey, we found it already in the dictionary. So it's fairly robust by putting in those statements. So by looking at it, it's a pretty robust program already. So we have a couple of other choices. So again, I'm going to go back to this level, that LF. And our third choice is redefining. LF choice equals 3. So now we have something very similar. We want to find out if this term, because they're going to put in a term and say, we want to change something. So I'm going to grab this, and I'm going to cheat a little bit. I'm just going to copy and paste and change this text. Please enter the term you want to change. And so we're going to get a value in from them. And so our first thing, if term in geek, and we're using a positive, so we're looking for one in there, then we're going to get a couple of pieces. We're going to say definition equals input. Please enter your new definition. And then we're going to assign that. So geek, whatever they entered as a term, equals definition. And then, again, we could put in a confirmation just so we know that it happened. It's always useful to tell your people using your programs the term has been changed. And then our else statement in here, else, we can just print that term doesn't exist. So these are all very similar in structure. We're just adding pieces to them. So we could delete one also, and the delete would work exactly the same way. So you could delete an existing term. So using that delete. But what I want to look at in a couple of minutes here is what happens if they enter a choice that's not on our list. So what do they do if they put in a 7? Well, out here at our list, we can clean this up a little bit. And I'm going to go out, back out to this outside, and I'm going to put an else, choice, and we don't even need to put a choice, do we? Because else covers everything. So anything else they do, you can just put a print statement in and say, listen, you didn't pick a value that we use. Try again. So the only other piece we need in there is our input to hold our programs open. And that's one thing I've seen a lot of people are already forgetting to put in at the bottom. At the very end of your program, this input serves a very valid purpose. So let me run this really quickly, make sure it works. Oh, I have a weird thing somewhere. Hold on here. If term equals input. Oh, I have that in one too far. Back. Chunk. Else. And back one. There we go. All right. Try that again. All right. So our program, we know that 0, 1, 2, and 3 work. We haven't done the delete, but I'm going to put in 7. Listen, you didn't pick a value. So anything I type that's not one of those values, notice that else clause handles it really nicely and takes care of that for me. Now, the one I don't have, if I hit 4, because right now there's no 4 in there, you're like, oh, that's weird, because we didn't go through and fix that one yet. But let me go through and show you why I'm so picky about making sure that that works. So this program, right now, we know it works, right? And if I run it, by just clicking on it, it pops up in this black screen. So this is running natively, not running that idle environment. It's running that program natively. And works the same way. So I can look up Python. So the program works. Well, let me show you what happens if I take out this statement at the end. Now I'm going to, close enough, and now I'm going to save that, file save. And so now that program is the same program, but we took out that input, and watch what happens. So in this case, that will work until I do this. Oh, it just disappeared, right? That input statement allows it to hang open when it runs natively. And so I may have actually wanted my program to disappear at that point, but it's really handy for a couple of reasons. And one of them is it's handy when I grab your program. I always try to run it just natively first out of that file folder when I pull them all down. And that tells me, hey, I need to look at what's going on there. So make sure you're putting those in there. I have a couple of people who have already turned in material, and you didn't put your name and your assignment, and you had no comments in there. These comments, and I know I didn't put a lot in here, but those comments are a great way for you to understand this program. I'm trying to show this structure, but quite frankly, if I'm writing something like this, I'm putting in a lot of comments about, all right, this is the choice for defining a term. Now, the other way sometimes we document it is with these print statements, because here I can tell what I'm doing with that print statement. But if I have a lot of code, so maybe I'm trying to solve a math problem or something else, those comments are what are going to save your bacon when you're trying to do things. I can put in comments about, up here I could say, geek is a dictionary, and that way if I look at that code and I'm trying to even help you, for example, or you send it to somebody else and they say, what kind of variable are you using? And you go, well, I thought I was using a dictionary, but how from this does somebody know, unless you tell them you're using a dictionary, that you're not just trying to do this? And you've just put the wrong symbols in there. So use those comment tags. They will help you. They will help us. All right. On Thursday, sorry. On Thursday, we're going to look at some additional pieces in this chapter, and we'll start hopefully giving you some ideas about how to create your program this week, about what you want to do with it and how you want to change that. All right, remember by midnight those assignments are due. If you have not done it and you look at your grade book, you're already going to see a 0 in there. Turn it in anyway. It will allow you to turn that in. But I wanted to go ahead and put those in, and then people seem to get panicked as soon as they start seeing zeros in there. All right, go out and enjoy the day. It's actually going to get to 45 maybe. And sprinkles and rain, but better than the snow that's in our forecast possibly for this weekend, which I don't quite see how that's going to happen.